Hello everyone, welcome back to my channel. This is the agronomy series. So today we will discuss about irrigation and water management. So what is irrigation? Irrigation is defined as artificial application of water for the purpose of supplying moisture essential to plant growth. So why we should irrigate? Okay, if the soil moisture is not enough for evapotranspiration of the crop field, then we must irrigate the crop to avail the moisture, to avail the nutrients, to increase the efficiency of the inputs. So by irrigation we ensure stable production, we ensure the increase in length of growing period, so that we can go for intercropping or multiple cropping. Then we can have some additional input feasible. Okay, feasibility of input. Okay, so we can easily increase the efficiency of fertilizer, increase the efficiency of pesticides, like that. So these are the purpose of irrigation. So what are the problems under excess irrigation? Due to excess irrigation, there is water logging or stagnation. There is soil salinization problem. Then there is suffocation kind of problem. The roots cannot aerate properly. They cannot respire properly, right? So these are the some of the problems if the area is totally inundated, like for sometimes, then there is problem of arsenic, nitrate, fluoride concentration, which may cause serious hazard. Then salinity hazard also we can assume there. So according to N.D. Gulati, irrigation in many countries including India is an as old as civilization, but for whole world it is modern science and science of survival, right? So irrigation water management includes development, application and utilization of water resources, water conservation, drainage, water quality and other aspects such as participatory irrigation management. What is consumptive use of water and what is conjunctive use of water? Consumptive use of water is the evapotranspiration from crop field plus metabolic use of water. That is consumptive use of water. And what is conjunctive use of water? It is a multi-source water use or multi-quality water use. Suppose we are using combinedly the groundwater and surface water, or we are combinedly using the fresh water and saline water, then that is known as conjunctive use, remember. So why drainage is important? Whenever there is excess water, we have to drain that water from the crop root zone, so that it can ensure that proper aeration of crop and it can ensure the proper growth of that crop. So total world water resources is around 1.5 billion cubic kilometer. Annual precipitation in India around in an average 1200 mm, and in world it is 1000 mm. So this 1200 mm over 328 million hectare geographical area, it comes to 400 million hectometer. So let's see the water budget of India. Okay, water budget, as I told you, 400 million hectometer. It is a total water, total precipitation in India, and from that percolated water is 215 million hectometer. What is percolation? That is the downward movement of water through the soil profile. So that is 215 million hectometer. Then immediate evaporation from that precipitation, that is 70 million hectometer, and surface runoff, that is 115 million hectometer. 115 surface runoff, percolation 215, and immediate evaporation 70. So total 400 million hectometer. From percolation 215 million hectometer, soil moisture contribute 165 million hectometer. From that, from irrigation, whatever we are irrigating, it adds another 5 million hectometer to percolating water. So total evapotranspiration, soil moisture 165, then irrigation plus 5 million hectometer, to total evapotranspiration it is available that 170 million hectometer in soil profile. Then groundwater, some water they store in soil profile, and another they percolate to the groundwater, right? To add the groundwater, right? That is 50 million hectometer. Okay, total 215, soil moisture 165, and 50 groundwater. Then generated from river, stream and irrigation plus 35 million hectometer, total 50 plus 35, that is total groundwater 85 million hectometer. and from that 85 million hectometer, utilizable groundwater is 43.3 million hectometer, and total present utilization is 12.8 million hectometer. Next, surface runoff, that is 115 million hectometer. Then regenerated flow from groundwater, due to capillary rise, there is regenerated flow from groundwater, that is plus 45 million hectometer. So 115 plus 45, then flows from outside India 20 million hectometer. So total surface water 180 million hectometer, and from that 180 million hectometer, utilizable surface water, that is 69 million hectometer, and present utilization is 31.12 million hectometer. So from groundwater, present utilization is 12.8 million hectometer, and from surface water, the present utilization is 31.12 million hectometer. So total present utilization 43.92 million hectometer. Okay, so Central Groundwater Board puts the annual exploitation groundwater potential at 43.3 million hectometer. Presently, the groundwater utilization is about 12.8 million hectometer, and a major portion of 85% being used for irrigation. Okay, so whatever total groundwater is used, it's utilized, from that major portion is used for irrigation, around 80 to 85%. Okay, the per capita availability of water has been steadily declined from 5,300 in meter cube per person per year in 1951 to 1,700 meter cube during 2007, and now I think it is declined to around 1,400 or 1,500 meter cube, which is scarce. Okay, the National Commission on Integrated Water Resource Development, Government of India, during December 1999 estimated that total water resources of the country at 195.3 million hectometer, and the total water requirement of the country as 69.4 to 71 million hectare by 2010, then 78.4 to 85 million hectometer by 2025, and 97.3 to 118 million hectometer by 2050. Okay, so this is all about water budgeting of India. Okay, so traditional irrigation processes. What are the traditional irrigation systems we used? Generally, swing basket method, picota, percolation, Persian wheel, then moat. Food security threshold of water is 2800 kilocalorie. Possible options that are available to meet the future irrigation and food needs are micro irrigation, change of cropping pattern, evaporation control and reduction of conveyance losses, recycling of water, interbasin water transfer, desalination of sea and groundwater in coastal area, rainfall by cloud seeding, and improved technology. These are some of the possible options which we can adopt for future irrigation problem on food needs. Okay, so problems of water, water resources in India. There are several problems like spatial and temporal distribution of that water, that precipitation, conflicting objectives of water resource development, then increasing sectoral competition between sectors, pollution of surface and groundwater resource, point and non-point solution sources of pollution are there, rising and falling of water table. These are certain problems of water resource in India. So available surface water flow in India is 186.9 million hectare. Ultimate irrigation potential of India is 139.89 million hectare. Total utilizable water resource including groundwater is 112.2 million hectometer. From groundwater it is 69, and from surface water 43.2 million hectare. Okay, so there are different categories of water. These are generally asked in different competitive examination. Blue water. What is blue water? Water present in sea, lakes, rivers. What is green water? Soil moisture and water in plants, that is green water. What is fossil water? That is the groundwater is known as fossil water. Grey water, wastewater from bathrooms, kitchens and wash basins. These are known as grey waters. What is black water? Domestic sewage and industrial wastewater, that is known as black water. What is virtual water? Water used in producing grains and animal products. Whatever clothes we are wearing, whatever water is used to produce any mobile phone or anything, that is known as virtual water, right? So system of irrigation. Different terminology are there, like gross command area, culturable command area, intensity of irrigation, annual intensity of irrigation, net and gross zone area, net and gross irrigated area, area to be irrigated. Okay, So when we said that gross zone area or gross command area, what do you mean by that? Actually, the net sown area is the area where actually we are sowing the crop, or net irrigation area where actually we are irrigating the water, and the rest of the area, which are, suppose some paths are there, some channels are there, these are comes under this plus net irrigation area or net sown area, that is known as gross command area or gross sown area. Okay, then intensity of irrigation, how much percentage of that area we are irrigating, that is intensity of irrigation. So area to be irrigated is equal to cultivable command area into intensity of irrigation. What is design capacity? That is the multiplication of time factor into channel capacity. What is duty? Duty, as I said in the previous video, duty is the ratio between area of crop irrigated and quantity of water applied. It is, the unit is hectare per cubic. Suppose we are applying 1 cubic of water, how much percentage of 1 hectare it is it can irrigate. So duty is area irrigated per cubic of discharge running for base period B. So what are the factors affecting duty? The types of crop, then climate and season, effective precipitation, nature of soil, management, environmental factor, management factor. These are the factors affecting duty. So duty of water required in designing an efficient canal irrigation system. Average duty for rice, remember, 775 hectare per cubic, and for sugarcane 730 hectare per cubic. 1 cubic day is equal to 8.64 hectometer. So way of considering canal water distribution system. Actually, there are two ways for considering canal water distribution system. In North India, they follow water allowance system, and in South India, they follow duty of water. Okay, what is rostering system? Rostering system is the process of irrigation water distribution. What is rotational irrigation? That is also known as Warabandi system. So there are different systems of irrigation based on sources of water. We have surface irrigation system and groundwater irrigation system. What is surface? What are the surface irrigation system? Like diversion system, reservoir or tank, then canal system. What are the groundwater irrigation system? Open well or dog well, bore or tube well, then artesian well, etc. Then according to Ministry of Rural Development, Ministry of Agriculture, so there are 3 kinds of irrigation. One is major irrigation project, medium irrigation project, and minor irrigation project. When the cultivable command area it is greater than 10,000 hectare, then that is known as major irrigation project. When it is less than 2,000 hectare, that is known as minor irrigation project. And when it is 2,000 to 10,000 hectare, it is known as medium irrigation project. Then based on purpose, one is single purpose, another is multi-purpose. Suppose we are using the command area or the water, the project for irrigation only, then that is known as single purpose irrigation. Then if we are using that project for controlling drought, controlling flood, etc., then that is multi-purpose use. Then based on financial return, we have productive and protective projects. Productive projects are having BC ratio, benefit cost ratio, greater than or equal to 1.5. So okay, what is okay, let's see. And some other terminology are there, like nominal duty. What is nominal duty? Area to be irrigated per mean supply discharge during the base period. Okay. What is core watering? That is the fast watering for the crop. Then what is core depth? The depth of water supplied during the first watering. What is the core period? The duration of the first irrigation. What is PALCO? First irrigation before sowing for seed germination and establishment. Then what is crop period? Sowing to maturity. What is base period? First irrigation for preparatory cultivation to last irrigation. Okay. What is delta? Volume of irrigation water applied to an area. Like it is, the unit are hectometer, million meter cube, then centimeter. Total depth of irrigation into numbers of irrigation. Okay. So we have different system of irrigation, as I mentioned. Okay. So for surface, like diversion system is there, then and which are weir and barrage, etc. Then reservoir, tank. When tank size is greater than 12 meter, it is called reservoir. There are grouped or connected tanks, then isolated tanks. Connected tanks means each tanks are connected, and water from one tank can move freely to other tank. Isolated tanks means there is no connection of that tank with other tanks. Then groundwater, open well or dog well, more the diameter and less discharge rate, like 1 to 5 liter per second. Diameter is about 2 to 9 meter and depth is about 20 meter. Then tube well or bore well, there are shallow tube well which have 20 to 70 meter depth and 15 to 20 liter per second the discharge rate. Then the deep bore well having 70 to 300 meter depth and 200 to 220 liter per second, it can generate the discharge rate. Okay, so actually this discharge rate based on the hole diameter. If the diameter of the hole is less, then it can discharge more water, and depth and depth and diameter. Okay, so again the bore wells are again divided into cavity type and screen type also. So these were all about some projects and some terminology of water management. So rostering system is also known as water distribution system. In irrigation is known as rostering system, and rotational irrigation is also known as warabandi. So then soil water relation. Okay, so soil water relation, efficiency of water in crop production is the function of when to irrigate, how much water to apply, and how to irrigate. This is actually the scheduling of irrigation water we'll cover. What is SPAC, soil plant atmosphere continuum? That is the function of plant characteristics, soil properties, and weather condition. Soil properties, as you know, there are 3 phases of soil, like solid phase, liquid phase, and gaseous phase. Again, water, what are the characteristics of water? Water is a bipolar molecule. It is V-shaped and the bond angle, HOH bond angle is 105 degree, and in 1 cubic centimeter there are 3.4 into 10 to the power 22 molecules of water can fit. Then water molecule cling to each other through hydrogen bonding. What is cohesion, what is adhesion, and what is surface tension? Cohesion is the attraction between same molecule. Then adhesion is the attraction between different molecules. Then surface tension, the value of surface tension of water is 72 dyne at 25 degrees Celsius. So there are several types of water. Like the physical classification of water, we have capillary water, gravitational water, and hygroscopic water. What is the capillary water? That water present in the micropore of soil. We have in soil section we have discussed what is micropore and what are the macropores. After rainfall, after about 2 to 3 days of rainfall, all the waters that are present in macropore, they move down to groundwater to add the groundwater. Okay, so the remaining micropores contain water that is known as capillary water. And the range of water potential in that capillary water range is minus 0.3 to minus 31 bar. Then what is gravitational water? That water that is percolated as groundwater to groundwater, that is gravitational water. That water is generally situated in macropores, and they percolate to add in groundwater. Then what is hygroscopic water? After 31 bar, that is the just a thin layer of water present outside the soil particle, that is hygroscopic water. It is hardly used by any plant. And what is biological classification? This was physical classification, capillary water, gravitational water, and hygroscopic water. What is biological classification? One is available water, another is unavailable water. What is the available water? That is the water present between field capacity to permanent wilting point, that is available water. And what is unavailable water? That is beyond, or that is beyond gravitational water and beyond hygroscopic water. Like the water potential is less than 0.3 bar and it is more than minus 31 bar. So that is biological classification of water. Again, we have in soil water relationship, we have like efficient use of irrigation water is the function of as I discussed, when to irrigate, how much water to irrigate, and how to irrigate. So specific gravity of soil. What is the specific gravity of soil? That is 2.65 gram per cc. What is particle density? Particle density is the mass of solid divided by volume of solid. The particle density is 2.65 gram per centimeter cube. Dry bulk density, that is mass of solid divided by total volume, that is the average dry bulk density is 1.33 gram per centimeter cube. Ideal bulk density for optimum crop growth varies from 1.2 gram per centimeter cube for clay soil and 1.4 gram per centimeter cube for sandy soil. What is total bulk density? That is mass of total, like mass of water plus mass of solid divided by total volume of that soil. Index of relative pore volume in soil. What is porosity? VF by VT, that is the area of soil covered by air and water divided by total volume, and the formula is 1 minus BD by PD into 100 for calculation region. What is the porosity that is ideal for cultivation? That is 30 to 60%. Types of pore space, there are macropores and there are micropores. Micropores are having the diameter less than 0.06 mm and macropores having the diameter greater than 0.06 mm. What is void ratio? Void ratio is the pore space divided by solid volume. Okay, volume occupied the pores divided by solid portion. What are the volume of soil solid? Okay, so that is around 0.3 to 2. Gravitational water content or mass wetness, how it is calculated? Mass of water divided by mass of solid oven dry soil. Okay, then what is volume content? Volume content of water, like gravitational mass content of water into bulk density. Then water content in depth basis, that is the volume basis water content into depth, soil depth. Then degree of saturation, what is the volume of water present in soil divided by volume of air. Okay, porosity. Then air filled porosity, that is volume of air divided by total volume of soil. International Society of Soil Science, IUSS, International Union of Soil Science, now it is known as International Union of Soil Science, that divided into the soil particles into clay, sand, silt, and sand fraction, and the larger fraction like 2 to 75 mm diameter, that fraction is known as gravel or pebble. 75 to 250 mm diameter, that is known as cobble if round, and if it is flat then it is known as flag. Then more than 250 mm diameter, that is known as stone or boulder. So what is the specific surface area of soil? Total surface area of particles per unit mass or unit volume of dry soil, that is known as specific surface area of soil. So for fine sand, the specific surface area is 0.1 meter square per gram. For silt, 1 meter square per gram, and for clay 10 to 1000 meter square per gram. Okay, so what is surface tension? Surface tension is the tension situated at air and water interface, that is about 72 dyne per centimeter or 0.072 Newton per meter. What is viscosity? Viscosity is the relation between drag force, that is in Newton per meter square, and velocity gradient perpendicular to direction of flow. Viscosity, the unit is poise. Okay, then capillary rise explained by Laplace's equation, that is rho WGH is equal to 2 sigma cos alpha divided by R is equal to 2 sigma by R. Okay, so how water is adsorbed into soil? That is due to two forces. One is capillary force, another is adsorbed force. Adsorption is the surface phenomena, and capillarity is in between pores. Then that are the forces like cohesion, adhesion, and surface tension also plays a role. Then saturated soil. What is when the soil is known as saturated soil? When the total micro and micropore are filled with water, then that is known as saturated soil. So let's see what are the soil moisture constants. Okay, there are several soil moisture constant or soil moisture characteristics curve. So what is maximum water holding capacity? When micro and micropores are filled with water and potential is 0 bar at that point. Okay, water potential is 0 bar, and micro and micropore both are filled with water, that is known as maximum water holding capacity. What is field capacity? Field capacity when micropores are filled with water, only micropores, and the water potential at field capacity is minus 0.1 to minus 0.3 bar or minus 0.01 to minus 0.03 megapascal. This is the upper limit of available water. What is moisture equivalent? That is moisture equivalent when the soil water is subjected to 1000 types of gravity. Okay, then the medium texture soil is the moisture equivalent is field capacity is equal to moisture equivalent. For sandy soil, the field capacity is greater than moisture equivalent, and for clay soil, field capacity is less than moisture equivalent. What is permanent wilting point or wilting coefficient? It is also known as wilting coefficient. It is the lower limit of available water, and the value of the potential of water at permanent wilting point is minus 15 bar or minus 1.5 megapascal. What is the value of hygroscopic coefficient? The water potential at hygroscopic coefficient is equal to minus 30 bar or minus 3 megapascal, and the water potential at ultimate wilting point is minus 60 bar or minus 6 megapascal. What is available soil moisture? That is the range between field capacity to permanent wilting point. So there are several concepts of soil water availability to plant. So broadly, like Weymouth and Hendrickson, they propose that water is equally available from field capacity to permanent wilting point. Whereas Richards and Wardley, they propose that water availability decreases with decreasing in soil moisture from field capacity to permanent wilting point. But modern concept says water equally available or readily available for plant from field capacity to a critical point, and from critical point it declines. Then moisture measurement of soil moisture. How we can measure soil moisture, right? So there are several techniques of measuring soil moisture. One is direct measurement, another is indirect measurement, right? So there are certain limitations and advantages, disadvantages of soil moisture measurement, different types of soil moisture measurement. So in direct method, we have feel and appearance method, like accuracy is about 5 to 10% only. Then gravimetric method, this is a direct method, and for calibration of any method we use generally gravimetric method. That is the weight of wet soil minus dry weight of oven dry soil divided by dry weight of oven dry soil into 100. And if we are proposing that in volume basis, then the weight basis moisture content into bulk density we have to use. So how to get that oven dry weight? That the temperature we have to set 105 degrees Celsius and wait till the soil is giving constant weight. Okay, then alcohol burning method. It is a quicker method, and at field capacity for 1 gram soil we can use 1 ml of alcohol, and permanent wilting point we can use per gram 0.5 ml alcohol. It doesn't recommended for higher organic matter soil. Okay, hot air drying, that is the use in gravimetric method. Then gypsum sorption plug, calibration is needed. Infrared balance, estimate in 5 minutes. There is use of 250 watt infrared lamp, and torsion balance and auto transformation is used. Okay, and then so then indirect methods of moisture measurement. One is gypsum or electrical resistance block. It is based on Wheatstone bridge principle. At field capacity the resistance is lower, like 400 to 600 ohm, and at permanent wilting point the resistance is very high, that is 50,000 to 75,000 ohm. Then again nylon block, it can measure the moisture up to -2 bar. Then plaster of Paris, it is up to -1.1 to -15 bar, and fiberglass, entire range of available soil moisture we can estimate using fiberglass method. Then Neutron scattering technique, we have Neutron moisture probe, and the source of neutron are americium and beryllium, and gas detector we use is boron trifluoride. So the slowed neutron after collision by water is measured in scalar and or rate meter. Okay, then gamma ray attenuation method, there we use 2 tubes. One is radioactive cesium 137, another is thallium activated sodium iodide detector. Principles followed is Beer's law and used in laboratory condition. Then TDR, generally in research institute we use TDR or time domain reflectometry, which is based on estimation of dielectric constant. The dielectric constant of water is 80, dielectric constant of dry soil is 3 to 6, and dielectric constant of wet soil is 20 to 30. Then microwave remote sensing, we use the backscattering coefficient method for microwave remote sensing, which is based on satellite sensor or synthetic aperture radar. Okay, then we have what happened in neutron scattering technique. We have probe containing source of fast neutron, americium and beryllium, and boron trifluoride gas as detector of that slow neutron, which is bounced back by water molecule. And a scalar or rate meter monitor the flux of slow neutrons that are scattered and attenuated into the soil. The first neutrons having range 2 to 4 mega electron volt, million electron volt, and average speed of about 1600 km per second collide with water molecule and converted to slow neutron, that is having lower energy 0.03 electron volt and speed of 2.7 km per second, and these are also called thermalized neutrons. Okay, slow neutrons detected by boron trifluoride and transmitted through electric pulse to the scalar and displayed the moisture content because this is already calibrated. What is the limitations of neutron probe? That is difficult to measure in topsoil. We work up to -2 bar only, not work properly in stony area. Then tensiometer. In tensiometer, we can continuously measure the metric potential or metric suction. It consists of ceramic cup, connecting tube, and vacuum gauge, and the limit is about -0.85 bar or -85 kilopascal. Then pressure plate or pressure membrane apparatus. We are using pressure plate or pressure membrane apparatus in laboratory measurement of soil water potential. This is used to generate that soil moisture, that curve. Okay, soil moisture characteristics curve. Here what happens, we apply certain amount of pressure and we calculate the moisture content at that pressure. Okay, so pressure applied from a compressor and maintained at desired level to draw soil moisture characteristic. Moisture content is determined against -0.1 to -15 bar in case of pressure membrane apparatus. To design a successful irrigation system, it is essential to know what is the plant rooting characteristics, what is the crop root zone, effective root zone, moisture extraction pattern of the plant, then moisture sensitive periods. Okay. What are the rooting characteristics? Rooting pattern, root proliferation and penetration depending on soil pores like hardpan, soil moisture, water table, toxic substances. Okay, effective root zone depth is the soil depth from which the crop extract most, nearly 90% of water needed to meet its evapotranspiration requirement. That is known as effective crop root zone depth. What are shallow rooted crops that are below 60 centimeter root depth? Those are cauliflower, cabbage, onion, potato. What is moderately deep rooted crop? About 90 centimeter the crop root zone depth. That is carrot, French bean, garden peas, chili, tobacco, wheat, castor, banana, groundnut, etc. Then deep rooted crop 120 centimeter depth. Cotton, tomato, watermelon, maize, sorghum, sugar beet, soybean, pearl millet. Then very deep rooted crop about 180 centimeter the root depth. These are lucerne, citrus, apple, guava, grape, coffee, tea, sugarcane, safflower, etc. What is moisture extraction pattern? Around 40% of the upper quarter, 40% moisture obtaken by the upper quarter of the root. Okay, then next quarter, quarter of depth, that extract about 30%, then followed next 25% uptake 20% of moisture, then the which roots are in deepest part, the 25%, they only uptake 10% of moisture. Okay, so 40, 30, 20, 10. If we go from upper surface to lower, okay, to the depth. Moisture sensitive period or critical growth stage of moisture is that period of crop during which moisture stress leads to greatest effect on quality and quantity of yield. That is known as moisture sensitive period. Like in if you say cereals like panicle initiation, tillering, these are the moisture sensitive period. In pulses, flowering and pod development, these are the moisture sensitive period. In case of sugarcane is the formative stage, grand growth stage. Then in case of maize, silking, then tasseling and silking, these are the moisture sensitive period. Okay, severe moisture stress during vegetative period drastically reduce leaf area index and leaf area duration. Moisture stress during flowering causes flower drops and pollen desiccation and offset of fertilization. Affects fertilization. Moisture stress during grain development leads to shriveled grain because the translocation of food material cannot be processed, and the low mean test weight also we can see due to slow translocation of photosynthesis. Then we have a different energy state of soil water. So total soil water potential is equal to metric potential plus osmotic potential plus gravitational potential plus pressure potential. In saturated soil, metric potential is 0, and in unsaturated soil, the pressure potential is 0. Quantity of water in mass basis, water potential is measured in joule per kg or org per gram. In volume basis, the unit is org per centimeter cube. Okay, in mass basis, if we measure the water, then the potential value is in unit joule per kg or org per gram. Or if we are measuring the water in volume basis, that is org per centimeter cube. Measurement of water potential, indirect method to measure soil water potential. Okay, soil water content. How we are like in tensiometer we are using metric potential. In pressure membrane pressure plate apparatus we are using metric potential. In thermocouple psychrometer also we are using. So this is the indirect method of measuring soil moisture content. Okay, so unit of water potential, the dimension of water potential in volume basis is ml1 t minus 2. The dimension of water potential in mass basis is L2 t minus 2, and in weight basis, that is the dimension is L. So unit conversions are there. 1 bar is equal to 100 kilopascal is equal to 0.99 atmosphere is equal to 14.5 psi pound per square inch is equal to 33.5 feet per head is equal to 10.2 meter head. 1 psi is equal to 2.31 feet head is equal to 6.9 kilopascal. 1 kilopascal is equal to 1 joule per kg. These are some of the conversion. Then soil moisture characteristics. What is soil moisture characteristics? This is the graph where a moisture content versus moisture tension is present. The moisture extraction curve or soil moisture characteristics curve strongly affected by soil texture, structure, and compaction. What is hysteresis? Hysteresis is also known as ink bottle effect, and it was proposed by Heinz. Hysteresis at a particular suction. When we draw the moisture extraction curve using the absorption and desorption curve at a particular suction, desorption curve has more moisture content than suction curve. That is known as hysteresis effect. So this effect may be due to geometric non-uniformity of individual pores, entrapped air, then swelling or shrinkage of soil. Okay, flow of water into soil. There are several terminology used. The infiltration, that is the flow of water from ground, the surface to ground. Okay, to the inner portion of the to the profile, soil profile, surface of ground to the soil profile, that is infiltration, the initial downward movement of water. Then infiltration velocity. What is that velocity of infiltration? That is known as infiltration velocity. Then what is the capacity of infiltrating water into that soil? That is known as infiltrability. Final infiltration rate or steady state. So certainly when rainfall occurs, the first initial infiltration rate is higher, and then it declines and it makes a constant infiltration rate, that is known as steady state infiltration rate. So generally we measure infiltration using cylinder like infiltrometer. There are single and double ring infiltrometer. In double ring infiltrometer, we avoid deep insertion into the soil, and outer ring act as buffer. Okay, so another measures of another methods to measure soil infiltration is ponding studies, discharge at 2 points, then estimation of accumulator infiltration from waterfront, advanced data. Okay, the coarse soil above fine texture soil develop, like suppose there is a coarse soil above fine texture soil, then water can easily move through that fine soil and it deposits over that heavy soil. So there is a paused water table develop, that is known as paused water table. Then what is percolation? Percolation is the downward movement of water through soil profile. Then seepage, infiltration, downward and lateral movement. Okay, so based on infiltration rate, we have like sand soil have greater than 20 mm per hour infiltration rate, sandy silty soil 10 to 20, then loam soil 5 to 10 mm per hour, clay soil 1 to 5 mm per hour, and sodic soil less than 1 mm per hour. Because in sodic soil the structural degradation occur and it hinders the water movement to downward. Okay, then Darcy's law. Darcy's law actually proposed by Henry Darcy. That law states that the quantity of water flow is directly proportional to area of cross section, and the change in head, like the difference in head, and inversely proportional to the length of that column. Okay, that is the directly proportional to area and the hydraulic gradient. Okay, that is del H by L, that is the hydraulic gradient per length, that is the driving force for water movement according to Darcy's law. So Q is equal to Q by A is equal to V by AT, and it is directly proportional to del H by L. K is known as hydraulic conductivity in Darcy's law. So the dimension of hydraulic conductivity in sandy soil is about 10 to the power minus 2 to 10 to the minus 3 centimeter per second, and for clay soil it is 10 to the minus 4 to 10 to the minus 7 centimeter per second. The rate of flow, downward rate of flow of water in vertical column is greater than horizontal column. Hydraulic conductivity is the function of soil porosity and tortuosity, entrapped air, fluid characteristics, and solute. How we can measure hydraulic conductivity? Using permeameter in laboratory condition, using constant head permeameter and falling head permeameter. Then in field condition, we have auger hole method or Hugout method, then pipe cavity method or Kirchhoff method. Then we have different kinds of flow, like saturated and unsaturated flow. Darcy's law applicable for both saturated and unsaturated water flow. Saturated hydraulic conductivity is higher in sandy soil, but unsaturated hydraulic conductivity is higher in clay soil. Unsaturated hydraulic conductivity is also known as capillary conductivity. Then vapor movement, that is through diffusion from warm to cold point of soil. Then plant water relationship. Okay, plant water relationship, around 80 to 90% of vegetation mass is consists of water, and more than 99% of water lost through transpiration, and less than 1% is used in metabolism. So sources of hydrogen for carbon dioxide reduction is water. Electron from reduction process of water actually splits in PS2 photosystem 2, and where electron generate, and that electron is act as reducing agent for carbon dioxide in formation of glucose. Then universal solvent, water is a universal solvent. Nutrient and photosynthetic translocation, it helps in nutrient and photosynthetic translocation. Then it helps in maintaining the turgidity of cells. Then major structural component it maintains. Then we have plant water movement through xylem basically, and through transpiration pool, that is a passive process. Okay. Then absorption water, mainly two types: active absorption and passive absorption. Active absorption is less than 10% of total absorption. Passive absorption is rapid, and here there is no energy is required, and this is due to transpiration pool. Active absorption required metabolic energy. Plant water status. Okay, water content of plant. There are several water content measurement. We can use the actual water content, that is fresh weight minus dry weight divided by fresh weight into 100. Water content at saturation, that is turgid weight minus fresh weight divided by turgid weight minus dry weight into 100. What is relative water content? That is fresh weight minus dry weight by turgid weight minus dry weight into 100. On the indirect method, we can use leaf temperature, canopy air temperature difference, then diffusive resistance, then transpiration rate. These are the indirect method of plant water status. Thermocouple or infrared thermometer, that is used for measuring leaf temperature and leaf water content also. Porometer also used for measuring leaf temperature, transpiration, stomatal resistance. Soil depth, from which crop extract most of the water to meet out its need, that is known as effective root zone depth, we have already mentioned, or design moisture extraction depth. If two or more crop of different rooting characters are to be grown together, in case of like intercrop, the design depth should be that of the crop having shallower root system. The design depth should be based on shallower root system. Okay. Moisture extraction pattern, like we have already discussed, the 25% moisture extracted from 40% moisture extracted from upper 25%, then adjacent to that 25%, 30% of water uptake, like that, 40, 30, 20 and 10%. So then shallow rooted crops are rice, onion, cabbage, cauliflower. Medium rooted barley, wheat, castor, tobacco, chili, peas, tomato. Deep rooted crops, cotton, maize, sugarcane, sorghum, palm, soybean. So moisture sensitive period or critical period, like I mentioned, cereal panicle emergence, flag, flowering, then for legume flowering and pod formation, for maize tasseling, silking, for tobacco entire growth for period, for sugarcane formative period, for wheat it is CRI, ground root initiation. Then evapotranspiration. Evaporation, from soil, water evaporates from canopy, that is the transpiration. So we cannot measure individually all of them, so we use the term evapotranspiration generally. Then okay, evaporation is a diffusive process, and temperature and energy required like 590 calorie per gram of water evaporation at 20 degrees Celsius. Water at evaporating surface greater than surrounding atmosphere. Factors controlling evaporation rate is surface soil moisture content, soil and air temperature, atmospheric humidity, wind velocity, vegetative cover. Transpiration is a necessary evil. It was proposed by Curtis. Due to transpiration, water uptake is possible, mineral uptake is possible, and carbon dioxide uptake and exchange important for photosynthesis. Actually, through transpiration, there is gaseous exchange also occurs in leaf. Evapotranspiration, what are the factors affecting evapotranspiration? Like climate, radiation, precipitation, relative humidity, temperature, wind. These affect the evapotranspiration. Then soil, water table depth, soil moisture, soil properties are also affecting evapotranspiration. Plant characteristics like morphology, crop variety, geometry, plant cover, stomatal density, root characteristics, growth phase, etc. affects evapotranspiration process. Or the management factors like tillage, fertility, plant protection, weed management, irrigation scheduling. These also affect evapotranspiration process. So there are certain methods by which we can calculate the evapotranspiration, like Penman method. PET, potential evapotranspiration, can be calculated in Penman method. So Penman defined potential evapotranspiration is the amount of water transpired in unit time by a short green crop completely shedding the ground of uniform height and near sort of water. Okay, there must be no water stress in that crop. Okay, empirical method of estimating ET, evapotranspiration. There are several empirical methods. Around 31 empirical formulas we have to evaluate, like estimate evapotranspiration. 4 are recommended by FAO. Three major steps for estimating evapotranspiration. First, we have to calculate the estimation of, we have to do the estimation of PET, potential evapotranspiration, or reference evapotranspiration. Then second, we have to determine the crop coefficient Kc value. Then we have to make appropriate adjustment to location specific crop environment. Okay, so okay, let's see them one by one. So first one is Blanik-Radial method. The formula is ET0 is equal to C into P into 0.46 T plus 8. Then radiation method, the formula is ET0 is equal to C into W into RS. Pan evaporation method, the ET0 is equal to K pan into E pan. Modified Penman method, it is mostly used because it consider all the weather parameter. ET0 is equal to C into W into Rn plus 1 minus W into Fu into EA minus ED. So what is crop coefficient? Crop coefficient is equal to ET crop by reference ET0, reference ET or ET0. Crop coefficient gives us information about date of sowing, length of growing season, and climatic data we need to generate crop coefficient. Informations we need to generate crop coefficient are date of sowing, length of growing season, climatic data like wind speed, humidity. So what is the length of growing season? Like initial stage, when germination to 10% ground cover is there, that is known as initial stage. 10 to 80% ground cover, that is known as crop development stage. Mid season stage, that is 80% ground cover to start of ripening. Okay, that is mid season stage, when there is maximum crop coefficient we can see. Late season stage, that is start of ripening to harvest, that is the late season stage. Average value of crop coefficient is 0.85 to 0.9, highest for rice, banana, coffee and cocoa, lowest for citrus, grape, pineapple and sisal. Higher in hot, windy, dry climate than cool, calm and humid climate. And crop coefficient vary among crop due to difference in reflectivity, crop height, roughness, degree of ground cover, canopy resistance to transpiration. When ET actual is less than ET0, that is considered as constant by available soil moisture and degree of canopy cover. So it is measured by atmometer, that is linear relation between water loss from atmosphere and evapotranspiration. Then evaporimeter, there are several types of evaporimeter we use, like USWB class A open pan evaporimeter is mostly used, then sunken pan evaporimeter, then portable evaporimeter. Then we use lysimeter. Lysimeter method is used to standard for calibration of other devices. So there are two types of lysimeter, like drainage type and weighing type. For drainage type lysimeter, inflow and drainage measurement happens, then changes in storage within soil is not measured. In weighing type lysimeter, evaporation of each element like rainfall, irrigation, runoff, drainage, evapotranspiration, etc. Measure. So lysimeter is used like there are weighing type and non-weighing type lysimeter is also there. Then according to FAO guideline for 80 measurement, reference evapotranspiration measurement, FAO irrigation and drainage paper, that is mentioned in paper 24. For crop water requirement, 4 methods are used, like Brannick-Radial method, radiation method, pan evaporation method, and evaporation modified Penman method. These are mostly used by FAO, recommended by FAO. And there is another FAO IDP paper 56 that recommend the only method is FAO Penman-Monteith method is suggested. Okay. 80 measure with hypothetical crop like 0.12 meter height, surface resistance should be 70 second per meter, and albedo is 0.23. Albedo must be 0.23. So measurement of water requirement of crop. How we can measure water requirement of crop? Quantity of water regardless of source needed for normal crop growth and yield, that may be supplied entirely by precipitation or irrigation or by both, that is known as water requirement. So consumptive use, as I mentioned, is equal to evaporation plus transpiration plus metabolic use. The metabolic use is less than 1%, so consumptive use is generally assumed to be 80. Water requirement is equal to evapotranspiration plus application loss of water plus water for soil moisture, like water for special operation, like what are the application losses, like percolation, runoff, and seepage, and what are the special operation like leaching, land preparation, then pre-sowing irrigation. These are the water for special operation. Then in terms of source of water, water requirement is equal to irrigation requirement plus soil moisture contribution plus effective rainfall, or irrigation requirement is equal to water requirement minus effective rainfall plus soil moisture contribution. What is net irrigation requirement? That is the amount of irrigation to be stored in crop root zone to reach field capacity or to meet consumptive use of water of crop. Cross irrigation requirement is equal to net irrigation requirement plus losses in conveyance, distribution, and application, etc. So factor influencing crop water requirement is equal to function of crop factor like duration, canopy cover, variety, leaf area, etc. Soil factor like hydraulic conductivity, reflectivity, thermal properties. Then climatic factor like solar radiation, temperature, relative humidity. So there are advection effect, Clothes line effect, and oasis effect are also there. So determination of crop water requirement, we have transpiration ratio approach. The transpiration rate is higher in C3 crop, followed by C4 crop, followed by CAM plant. What is transpiration ratio? It is the amount of water transpired by crop to produce unit quantity of dry matter. Then again, depth interval yield approach is also there to measure the crop water requirement. Then soil moisture depletion study we also can use. The formula is consumptive use is equal to M1I minus M2I divided by 100 into PDI into DI. Seasonal consumptive use is the sum of daily consumptive use. What is field experiment? In field experimentation, we can use the water requirement is equal to irrigation requirement plus effective rainfall plus that consumptive use, what I mentioned earlier. Then climatological approach is also we are taking, like IW by CP ratio. Then Dastane proposed drum culture method to measure water requirement. It is generally used in lowland rice. Then it can measure percolation, evaporation, transpiration, and ineffective rainfall. The drum size taken is the dimension is 50 into 50 into 120 centimeter. So effective rainfall. What is effective rainfall? So what is effective rainfall? Effective rainfall is the fraction of total rainfall that is available for consumptive use of the crop. In case of arid and semi-arid region, the effective rainfall is 70%, and in humid region, the effective rainfall is less, like that is 50%. So what are the factors affecting effective rainfall? One is the rainfall characteristics like amount, intensity, and distribution of rainfall. More the rainfall, less the effective rainfall. Then again, land characteristics like topography, opportunity time is depends on topography. If the land topography is less, like if it is a plain land, then the opportunity time is more, and if it is a slopy land, then opportunity time is less. So land topography also affect effective rainfall. And soil characteristics like texture, structure, BD, organic matter, water holding capacity, water stable aggregates, these are affecting effective rainfall. Then groundwater characteristics like effective rainfall higher with water table is deeper, when water table is deeper. Then management practices like crop management practices, whatever we are weeding, tillage, fertilizer application, these are also affecting effective rainfall. Then crop characteristics like rooting behavior and all, so that also affect effective rainfall. Effective rainfall is directly proportional to the rate of water uptake, degree of ground cover, root zone depth, growth stages, etc. So how we can determine the effective rainfall? Effective rainfall is determined by USDA soil conservation service method, Ramdas method, integrating gauge method, ET by precipitation ratio method, PET by P ratio method, soil moisture change method, that is effective rainfall is equal to M2 minus M1 into crop coefficient plus crop coefficient into PET. Then soil moisture balance method, that is moisture depletion balance method, like rainfall plus irrigation requirement. Then measurement of irrigation water. How we can measure irrigation water? What is the quantity of flow of water? That is area, cross-sectional area into velocity of flow of the water in that area. So what are the units used generally? Like 1 hectare centimeter, we have 1 lakh liter of water. In 1 hectare centimeter, in 1 meter cube, we have 1000 liter of water. So in 1 hectare centimeter, we have 1 lakh liter of water. Units are, when water is in rest condition, the units are meter cube, liter, hectometer, like that. When it is flowing, then the units will be cubic, LPS, cubic, gallon per minute. These are the unit. Then measurement of water in water flow in open channel. That is, first one is velocity area method, that is based on float method. Average velocity is equal to 0.8 into surface velocity. Then discharge, direct discharge method. Okay, so other velocity area method like current meter, we are having COP type or propeller type current meter we can use. Then tracer method, we can use salt dilution or radioisotopes to measure the velocity. Then a direct discharge method, we have OARs that are notch. On the basic equation is Q is equal to CLS to the power M. L is the length of the OAR crest and H is the head or depth of water. Then M is for rectangular or trapezoidal OAR, it is 1.5, which is used to measure uniform flow. Then triangular OAR, it is 2.5, that is used in variable flow measurement. Then a parabolic OAR, that is the value of M is 3.5. Then flume is suitable for silt laden water. Generally there are several types of flume we can use partial flume, cut throat flume, S flume, trapezoidal flume, or WSC flume. Partial flume has conversion section, throat, or constriction section, that is divergent section. Then orifice, this is used for free discharge, subsurface orifice, and head. Okay, Q is equal to C into 10 to the power minus 3 surface area into root over of 2gh, that is for orifice. Then measurement of flow in pipes, quantity is equal to volume of water liter divided by time required to flow that water, to fill that water into 60. Flow rate measuring device such as Venturi meter. Flow of water in pipes, we can use Venturi meter we can use. Then pipe orifice, Q is equal to C8 root over 2gh. Then coordinate method, Q is equal to AV. Water level recording by laminograph. The measurement of cumulative flow, irrigation meter, low pressure line meter, open flow meter, vertical flow meter. Then irrigation scheduling. What is irrigation scheduling? When to irrigate, how much water to apply a crop, okay, and when to irrigate, right? This is for irrigation scheduling. By irrigation scheduling, we can efficiently use the whatever water is available and we can increase the crop productivity. What are the approaches of irrigation scheduling? One is soil moisture regime approach, that is fill and appearance method, gravimetric method, DASM, depletion of available soil moisture method. Then climatological approaches are like IW by CP ratio, CAN evaporimeter. Then plant indices like visual symptoms, soil comp sand mini plot technique, where we can add 5% sand. So more sand means more rate of evaporation percolation, so the water stress will be earlier. Then increased plant stand, like 4 times we are increasing the plant stands. Then a reduction in growth rate approach also there. Then how much to apply? This was about when to apply the irrigation and the strategies. Then how much water to apply, how we can assess, that is the net irrigation requirement, that is the amount of irrigation water required to bring the soil moisture in the root zone depth to fill capacity. Net irrigation requirement is equal to MFC minus MBI divided by 100 into BT into DI. Then gross irrigation requirement, that is the net irrigation requirement divided by efficiency of irrigation. Then irrigation interval or design interval is the net amount of moisture between fill capacity and starting level divided by peak period moisture use rate, that is net depth of application divided by peak period use rate. Irrigation period, numbers of days that can be allowed for applying one irrigation to a given design area during the peak period consumptive use of crop under consideration, right? That is net amount of moisture between starting of irrigation and lower limit of moisture depletion divided by peak period moisture use rate of the crop. So what are the methods of irrigation? One is surface irrigation, or that is based on gravity irrigation, that is wild flooding and control floodings are there. In control flooding we have basin, check basin, border strip, region furrow, surge irrigation, cabligation, corrugation. These are surface irrigation methods. And then sprinkler or overhead irrigation method. Another one is drip irrigation or trickle irrigation method. Trickle irrigation method or drip irrigation is having highest efficiency in terms of irrigation. The water discharge in trickle irrigation method or drip irrigation method is 1 to 10 liter per hour per emitter, and the pressure is 1 to 3 atmosphere, that is 15 to 45 psi. Then there are surface trickle, subsurface trickle, low head bubbler method, and then micro sprayer drip irrigation. Then mechanical pulse irrigation is also there. Then average depth of application in border strip, that is DA is equal to Q into C into T divided by WB and LB, where Q is equal to stress line, that streamline size, that is LPS in terms of LPS. C is equal to constant, that is 360. T is equal to time, and WB is the width of the border, LB is the length of the border. Border irrigation is suitable for close growing row crops, right? Furrow irrigation is most suitable for potato, maize, cotton and various vegetable crops. Alternating furrow irrigation with border irrigation is the next crop in rotation may facilitate leaching and reduce the danger of salinization. So how to measure the non-erosive flow, that is QM is equal to 0.60 divided by S. Q is equal to flow, that is in LPS, liter per second. S is the slope percentage. Average depth of water application, that is Q into 3600 divided by furrow spacing into length of furrow. Surge irrigation, that is modified furrow method, where automated on-off system is there and gated pipe T arrangement is there. Cabligation is the gated pipe arrangement and cable cutback effect. Corrugation is the partial surface flooding method of irrigation, where water flow in reels useful for small grain crops like wheat. Irrigation and water use efficiency. Soil having infiltration rate greater than 15 cm per hour, limit above which gravity irrigation causes excess loss. For online canal in permeable soil, seepage losses may account for 20 to 30% of total irrigation supply. Irrigation efficiency is around, in Indian condition, irrigation efficiency is around 20%. Okay, what are the different irrigation efficiencies? Water conveyance efficiency is equal to water delivered to the plot divided by water diverted from the source. Suppose we are irrigating a plot from a pond, we are taking that water. So whatever amount of water we are diverting from pond, whatever amount of water that is diverted to that particular plot divided by water diverted from the source, like from pond. So this is about conveyance efficiency. So if conveyance efficiency is low, we can assume that when maximum water loss occurs during the transit period. Then water application efficiency, that is water stored in the root zone divided by water delivered to the plot. Water application efficiency for surface method is 40 to 80%, for subsurface method is 50 to 80%, and sprinkler is greater than 80%. Water storage efficiency, that is water stored in the root zone divided by water needed in the root zone for prior to irrigation into 100. Water distribution efficiency, that is the 1 minus deviation from mean divided by mean into 100. Project irrigation efficiency, that is water stored in the root zone depth for consumptive use divided by water delivered from the source into 100. Also it is project irrigation efficiency is also known as farm irrigation efficiency or field irrigation efficiency. Defective design or poor management leads to low operational efficiency. Consumptive use efficiency, that is consumptive use of water by crop divided by water depleted from the root zone into 100. Crop water use efficiency, that is marketable crop yield. Remember, marketable crop yield divided by T. Okay, crop water use efficiency is equal to marketable crop yield divided by ET. Field water use efficiency is equal to marketable crop yield divided by water requirement. So what are the factors influencing water use efficiency? There are agronomic practices, soil type, climate, management factors. These all factors affect water use efficiency of crop. Water use efficiency is generally highest in CAM plant, followed by C4, followed by C3 crop. Then there are certain crops and their water use efficiency. Remember all this. For rice, it is the lowest, 3.7 kg per hectare millimeter. For finger millet, it is the highest, that is 13.4 kg per hectare millimeter. For finger millet, it is 8 kg per hectare millimeter. For maize, it is 9.2 kg per hectare millimeter. For sorghum, it is 9 kg per hectare millimeter. For wheat, it is 12.6 kg per hectare millimeter. And for rice, okay, I have already covered. So you have to remember all this. And water use efficiency, the unit is kg per hectare millimeter. Then water control structure, we have a certain structure to control the water. That are siphon tubes, piles, check dams, turnout boxes, junction boxes or check gates, alfalfa valve, hoga, hydrants, etc. Irrigation practices in major crops, we generally intermittent irrigation reduces losses of nitrogen from rice. Quality of irrigation water, we have different problems with when we use poor quality irrigation water. So there are salinity hazard. So what are the units of measuring salinity? One is millimoles per centimeter. 1 millimoles per centimeter is equal to 1 decicement per meter. Then TDS, we use total dissolved salt in ppm, milligram per liter, that is 640 into EC. TDS is equal to 640 into EC. Then megapascal in case of metric potential we use. So pressure potential or potential of water is equal to minus 0.036 into EC. Total ion equivalent, if we use, then milli equivalent per liter is equal to EC, decicement per meter, into 10. So these are some of the conversion you have to remember. TDS is equal to 640 into EC. Metric potential is equal to, water potential is equal to minus 0.036 into EC, and total ion is equal to 10 into EC. Water type and TDS. So in fresh water, total dissolved salt is less than 500 ppm. In marginal, 500 to 1500 ppm. In brackish water, 1500 to 5000 ppm. In saline water, more than 5000 ppm. In brine water, greater than 35000 ppm. In beton water, more than around 350,000 ppm. So these are salinity hazards. And sodium hazards like SAR, we used generally SAR and RSC, residual sodium carbonate. What is SAR? SAR is equal to sodium concentration divided by root over of calcium plus magnesium divided by 2. Okay, residual sodium carbonate, the formula is carbonate plus bicarbonate minus calcium plus magnesium. Then toxicity hazard of high concentration of boron, fluorine, selenium, etc. Then classification of irrigation water, there are like 4 salinity classification, and another 4 is sodicity classification. Low salinity water is having EC less than 250 micromole per centimeter or less than 0.25 decicement per meter. That is assigned, C1 is assigned for that. Then medium saline water, the EC is between 0.25 to 0.75 decicement per meter, and that is assigned as C2. And high salinity water, C3, is from 0.75 to 2.25 decicement per meter. Then very high saline water, the C4, that is EC is greater than 2.25 decicement per meter. Then low sodium water when SAR is less than 10, medium sodium water the SAR is 10 to 18, high sodium water that is the SAR is 18 to 26, very high sodium water the SAR is greater than 26. Then crop tolerance to boron tolerant crop having 2 to 4, it can tolerate up to 2 to 4 ppm boron. Those are date palm, sugar beet, berseem, onion, cabbage, carrot. Then semi-tolerant crop, it can tolerate 1 to 2 ppm boron, sunflower, potato, cotton, barley, lemon, maize, sorghum. Boron sensitive crop can tolerate around 0.3 to 1 ppm boron, apple and grape. Then managing poor quality water, we can apply gypsum in water favorable to favor the calcium sodium ratio and calcium magnesium ratio. Then growing tolerant crops like barley, sugar beet and rapeseed. Then method of sowing is also important. We have to sow the seed in side ridges, and transplanting we have to do transplanting. Transplantings like samplings are more tolerant to salinity hazard. Then closer spacing we can grow, and fertilizer use we can selectively use the fertilizers. Then irrigation and drainage facility must be there. Then soil management, we have to manage the soil accordingly. Then drainage, what is drainage? Drainage is the removal of excess water from crop root zone depth to optimize the to balance the soil water and porosity. What are the causes of waterlogging? Okay, and what are the effects of poor drainage? Okay, I told you in brief. Then what are the types of drainage? Drainage are surface drainage like random system, parallel or field ditch system are there, perpendicular open ditch system are there, like diversion ditch system. Then bedding system is there, where slope is less than 0.5%, we can go for bedding system. Then interception system or cross slope ditch system, when slope is greater than 2%, we can use. These are the surface drainage system. Then subsurface or groundwater drainage system, we have pipe or tile drain, we have mold drain, then we have drainage well also. Then another is bio drainage. We can use the bio drainage crop like eucalyptus, which can uptake more water through its evapotranspiration. It can drain waters. Then what is drainage coefficient in 1 hectare? From 1 hectare in a day, what amount of drainage we have to do? That is the drainage coefficient, that is 1.157 liter per second. So how pricing of irrigation water is done? It is done based on flat rate pricing or volumetric pricing. Sharma and Sharma in 1990, he proposed around like 3 kinds of pricing, irrigation pricing, that are cost per hectare criteria, benefit cost ratio. It is adopted, benefit cost ratio is adopted by Irrigation Commission, and there is internal rate of return is also there. So benefit cost ratio, if it is normal rainfall area, then the benefit cost ratio should be 1.5, and if it is drought prone area, then benefit cost ratio should be 1. Okay, so let's discuss some of the important MCQs that are asked in different competitive exams. So a critical stage for irrigation in groundnut, that is pegging stage. For sugarcane, it is formative stage. For maize, it is tasseling stage. On the basis of design capacity, an irrigation project, the basis of design capacity for an irrigation project is known as irrigation period. Term moisture equivalent was given by Briggs and Sands in 1912. Concept of capillary potential was given by Buckingham. Crop sensitive to moisture during entire growth period, that is tobacco. Crop sensitive to both waterlogging and drought, that is maize. And Waterman of India, who is known as Waterman of India, Rajendra Singh. Then tensiometer, that is also known as aerometer, the potential up to which tensiometer works well, that is 0.85 bar. Water content of wood of large trees on fresh wood basis about 40 to 60%. Now, tank irrigation mainly adopted in Tamil Nadu. Cultivable command area for major irrigation project is more than 10,000 hectare. As per World Health Organization, safe level of nitrate in drinking water, that should be 10 ppm or 10 milligram per liter. Relationship between crop yield and evapotranspiration, in case of cereal it is linear, and in case of pulses it is quadratic. Effective rainfall for arid region is about 70%. Effective rainfall for humid region, it is about 50%. 1 cubic is equal to 1 feet cube water flow in 1 second, that is 0.0284 meter cube per second. Irrigation efficiency for wild flooding is about 20 to 25%. Drip irrigation was first patented in 1964 by Simca Blas. Ultimate irrigation potential in India is equal to 139.9 million hectare. Command Area Development was renamed as CADWM in 2004. Areas where water lifting up to 80% of groundwater recharge is permitted, called as gray zone. Remember, area where water lifting is up to 80% of groundwater recharge is permitted, that is known as gray zone. Leaf temperature is measured by porometer. Percentage of extracted moisture from each quarter of root: 40% from first quarter, then another 30% from second, then 20% from third, then 10% from fourth quarter. Evapotranspiration watershed can be measured by water balance method. What is gray water? That water from bathroom and kitchen. Drainage coefficient, that is the value is 1.157 liter per second. Semi-automated deep irrigation is known as cabligation. Cycle ratio for surge irrigation is 0.25 to 0.75. Surface drainage not used in flat areas. Okay, that is interception system. That is used in more slopy areas, right? Then a crop sensitive, okay, tensiometer value we have already covered. PF value at field capacity, that is 2.54. PF scale, that is given by Schofield. The value of PF at field capacity is 2.54. The value of PF at permanent wilting point is 4.18. Gypsum block was given by Boykos and Meek. That is not suitable for saline soil. Neutron moisture meter is not suitable for organic soil. Sunken screen evaporimeter it was developed by Sharma and Dastani. On and off irrigation is otherwise known as surge irrigation. LEPA is a modified sprinkler irrigation. Fast irrigation before sowing is known as PALCO. For sandy soil, moisture equivalent is less than field capacity. On saturated soil, pressure potential is 0, and saturated soil, metric potential is 0. In India, maximum available utilization for irrigation is in India, whatever fresh water we used, maximum water is used in irrigation purpose, that is around 80%. Irrigability class not suitable for irrigation agriculture, that is class E soil. Value of leaf water potential in soil plant atmosphere continuum is -5 to -20 bar. Consumptive use, that is evapotranspiration plus metabolic use. Conjunctive use, that is either multi-source water use or multi-quality water use. Then principle of TDR based on dielectric constant. Water movement always moves from lower tension to higher tension, higher water potential value to lower water potential, or lower DPD, diffusion pressure deficit, to higher diffusion pressure deficit. Plopping is related to tobacco, that is wilting of tobacco in waterlogging condition. Canopy temperature depression, positive indicator of heat stress in plant. Okay. The ratio of number of stomata to the total number of cells in an unit area is known as stomatal index. So students, this is all about a brief lecture on irrigation water management. We will upload each an individual concept again, one by one. We can upload. I am working on that. So stay tuned with my channel and stay benefited. And if you have any doubt at any point, you just can ask me in the comment section. Thank you guys.